called this an HEQ5 Backlash tutorial. Actually, it's not restricted to the HEQ5, but to any mount with similar mechanisms for RA and DEC. And it's not really just a Backlash tutorial, it's really about the engagement of the gearing inside your mounts and getting that engagement optimized. So let's start by exploring what a worm drive is, because the HEQ5 has two worm drives within it. A worm drive mechanism actually involves two parts. The first was the worm drive itself, and the second is the worm gear that the worm drive engages into. And the great thing about this arrangement is that it enables a very high ratio between the number of turns of the worm drive required to the number of turns that result in the worm gear. And that's good for moving things at slow speed, which is exactly what we want on a tracking mount, but also gives you a high torque, which again is what you want because you're potentially carrying quite heavy loads. So it's really ideal for this kind of job. And so it's often used in mounts for the right ascension and declination drive. But the amount of engagement that you have between the worm drive teeth and the worm gear teeth is really critical. It has to be set up right, or bad things happen. Now, this is a simple diagram of two gears meshing, and in this diagram they're not meshed enough, and the result is that you have these gaps here. See the gap here and the gap here, and these result in what's called backlash. If the top gear was rotating clockwise, then the bottom gear would turn with it, and that would seem to be fine. But if it then stops and tries to go back the other way, there's going to be a period of time where the top gear is moving, but the bottom gear is not moving at all, because the top one is moving across this gap. And it's not until it reaches the other side of the gap and touches the bottom gear that the bottom gear starts to move again. So that's called backlash, and that's bad in astrophotography, because in particular when you're auto guiding, the auto guider is trying to send corrections to the mount to nudge it in one direction or the other as the star moves around on the guide camera image. And if when it tries to move in one direction it moves, but it tries to move in the opposite direction it initially doesn't, that can make guiding very difficult. So we don't want backlash. Too far apart, the gear and the worm too far apart is what causes backlash. However, there's also another nasty, and that is that when the gear and the worm are too close together. And when that happens, you can get excessive wear on the surface of those the worm gear and the worm drive. But in the limit, you can also get what's called binding, where the whole mechanism kind of seizes and refuses to move properly or smoothly, and it starts presenting significant resistance. And that's bad too, because your mount will just fail to move when you need it to. So you've got this very fine line between the gear and the worm being too far apart and having a backlash problem, and too close together and binding. So what does the worm drive gearing system look like inside the HEQ5? So this is a worm gear, and I'm not sure if this is the RA or the DEC, but they look very similar to one another. You can see that it's quite a hefty piece of machined metal. You can see the teeth machined into the rim of it, and that it's got quite a significant bearing inside it. So this worm gear is mounted on its bearing so that it's free to rotate, and it's attached to the part of the mount that needs to move. The worm carrier is the structure that holds the worm drive, and this is the worm drive, and on the end of the worm drive there is another gear, which is the driven gear. So the motor that's driving the axis will turn either via another gear or via a belt. If it's a row and belt modified version, will drive this gear on the end of the worm. That causes the worm to rotate, and the worm then causes the worm drive causes the worm gear to rotate. So other things to notice on the carrier: there are 3 holes for bolting the carrier onto the body of the mount, and there are also these 2 little black grub screws, which are really important for making adjustments, and that will become clear in a moment. So this is what it looks like when the gear is engaged into the worm, and you can see it's suitably lubricated with grease in this photo as well. Now the other important thing is that on the body of the mount there are blocks, rigid surfaces made of brass, bolted in, which are for the grub screws to push against in order to enable you to move the carrier in order to change the engagement between the worm drive and the worm gear. So in this diagram from the Astrobaby website, which I highly recommend, actually, a very good website. It's got lots of instructions for how to strip down and rebuild your HEQ5 and other Skywatcher mounts, and also gives instructions for doing this tuning process. So what we essentially have for each axis is the body of the mount. We have the worm gear mounted on its bearing, and we have the worm carrier, which is shown with this dotted line, bolted hard down onto the body of the mount, and holding onto the worm drive. And the worm drive has actually got two small bearings on its shaft, so that can rotate but still be rigidly attached to the carrier. Now you can see that the carrier and worm need to move either to the left or the right in this diagram in order to change the amount of engagement between the worm and the gear, and that's achieved by moving these grub screws or set screws, and you can see, because they oppose one another, if you want to move the carrier you need to do up one whilst undoing the one opposite. So for example, if I wanted to move the carrier to the right, then I would undo the left hand grub screw a bit and then screw in the right hand one. Now the carrier would only move, and I would only be able to screw the right hand one in, if I had loosened the three bolts that hold the carrier to the body of the mount. So that's the first thing, is to loosen those screws just enough that the carrier can slide over the surface of the mount along this interface, and then to loosen one screw and then tighten the other in order to move the carrier and change the degree of engagement. So similarly here, if we were to unscrew the right hand grub screw and tighten the left hand one, then the carrier would move to the left and we would have less engagement between the worm drive and the worm gear. So before you start messing about with your mount, taking it apart and adjusting your backlash, it's important to know how to find out whether you've actually got a backlash issue in the first place. So I've got three possible ways of doing that, and to be honest, the first one is the one that I tend to use the most, and I call it the rock test. Put your mount on its tripod and secure it so it's not going to fall off. Do up the clutches, and then for the deck here, just grab a hold of the top and just gently try to rotate the deck forwards and backwards. If it shifts a little bit and makes a knocking sound, then you have significant backlash. And you can do the same test in right ascension. Just drop the counterweight bar out and grab the counterweight bar. Don't exert too much force here because you've got a fair bit of leverage, but just be gentle, but see if the RA will rock, and if it rocks, makes a little knocking sound. If it doesn't, then you haven't got too much backlash. There's also something I call the worm turn test. This is underneath the cover in my mount, and you can see the row and belt modification that I have on mine. This is a little harder to do the worm turn test if you don't have the row and belt mod, because there would be another gear meshed in between the motor gear and the gear on the end of the worm. But on the row and belt modified one, it's much easier. You simply remove the belt and then you can grab a hold of the gear on the end of the worm and rotate it gently forwards and backwards, and look to see, does the mount always move when I move the gear, or is there a little bit of movement of the gear when I change direction? Is there a little bit of movement of the gear without the mount moving, and then the mount picks up and starts moving as well? If there's that little sort of delay before the mount starts moving when you change direction of rotation, then it looks like you've got some significant backlash. The final test is really for people who use PhD2 to auto guide, and obviously a lot of people do, and it's called the cross test. If you look in the menus, you'll find the cross test, and you need to have a piece of software capturing a long exposure shot from your camera, and you set up the cross test and you start a long exposure and run the cross test. And what happens is that the the program PhD2 will send instructions to the mount to move it forward a set amount in RA, and then back by double that amount, and then forward by the original amount again, back to the original position. And then it will do the same thing in the deck. And the result should be that it should form a cross shape on each star in the photo that the camera has taken while it's done this set of maneuvers. If you have significant backlash, you can get a very different result. And this is from my mount when I had significant declination backlash. You can see that the RA has moved fine, forward, back double amount, forward again, and then it started moving in deck up this way. But then when trying to move back the opposite way, there's been this delay, and eventually it's picked up, and it's only got back as far as here instead of ending up down here because of a declination backlash. So 3 different ways of telling if you have a backlash issue. So I'm now going to show you a video of how to tune your HEQ5 backlash out if indeed you have it, and I'm going to start with declination. So I've set up the mount on its tripod legs indoors. I've got power to the mount and the controller connected, and the mount is secured. We'll do up the RA clutch and the deck clutch. Now we can do the rock test on the declination. And in this example, there's no apparent backlash. Now we do the rock test on the RA, and again, no apparent backlash. Now here I've deliberately introduced backlash, and you can see the deck is rocking slightly. I'm now going to turn the mount around in RA and take the cover plate off so that we can get to the drive motors and the belts and the end of the worm drives, so that we can do the worm turn test. This is the declination worm end with the drive motor, and this is the RA, and these are the gears on the ends of the 2 worm drives. So there are 3 of the 6 screws that need to be loosened to take the belt off, so be careful to undo the correct ones. The other ones hold the plate to the end of the motor. You don't want to be undoing those. Once the motor's loose, you can push it in to slacken the belt, and then gently ease the belt upwards off of the teeth on the large gear on the end of the worm until the belt comes off. Now the belt's off, we can do the worm turn test on the declination. And on the right ascension would be exactly the same process. When you come to put the belt back on, fit it to the motor gear first, around the idler, and then onto the worm gear. Make sure it's nicely aligned, and then pull the motor back to tension the belt, and just pop a screwdriver into that gap there, just a very slight twist just to put a little tension on the belt. Do not over tension the belt or it will stretch. Tighten up the motor screws a little, and then test the tension. There should be 2 millimeters of deflection with a gentle push. When you're happy with the tension, you can tighten those 3 screws up firmly so that it doesn't move. I'm just checking that the RA and declination tensions are about the same. Then we can put the cover plate back on. So that was the worm turn test. Okay, so we know that we have a declination backlash. We can see and hear that that's happening with the rock test. So the first thing to do is to loosen the screws holding the declination worm carrier to the mount. You'll notice that I'm actually retightening them, but very gently after doing the main loosening, so that they're not too loose. They're just loose enough so that the carrier can slide, but you don't want it to be flopping around essentially. So each screw is being loosened off and then gently retightened until it just about stops. and no more. So the carrier is now slightly loosened, and now we can adjust the first of the grub screws. So on the flat side we need to undo the grub screw to allow the carrier to move the worm towards the gear, and now tighten the grub screw on the curved side to pull the carrier and the worm towards the gear. And then we test again with the rock test, and you can see we still have declination backlash. So I will again loosen the grub screw on the flat side. Just a quarter of a turn is sufficient, and then tighten on the curved side. That's an eighth of a turn, and the closer you get, see that the backlash has reduced, but it's still there. The closer you get, the smaller the adjustments, and I would recommend when you get very close that you make adjustments of no more than a 16th of a turn. So really very small adjustments. There I'm still making an eighth of a turn adjustments, and you can see the backlash is getting smaller every time. Really important to take your time over this process. Don't rush it. You don't want to go too far. If you go too far, you'll get binding problems, and you'll have to go back and do it again. So just very small adjustments each time, and test each time to see what's happening. So very, very slight backlash still there. So I now know I need to be making very small adjustments indeed. Just a little bit of undo on the flat side, and then tighten on the curved side. Really small amounts now. Just taking out any slack in the bottom screw there, drop screw. It's getting very close indeed, but there is still a little bit, so I'm just going to loosen just a 16th of a turn there, and tighten on the curved side, just a very small amount, 16th of a turn, no more. Take out any slack and test again, and now it really is very, very close indeed. And very, very small tweak left to do. Take out the slack on the bottom side. It really looks very good now. There's no obvious backlash at all. So once you've made that adjustment, you need to tighten the carrier down. That's really important, not to go in and crank one bolt hard down. Work your way around the 3 bolts, apply a little bit of a tighten on each one, and rotate around the 3 bolt heads a little bit more and a little bit more. It's really important to do this to stop the carrier shifting while you're doing the tightening. If it shifts, you have to start all over again. So really take your time, be very gradual in the way you do this up, and make sure by the time you've finished that all 3 of those bolts are really secure. Don't go crazy, but they should be tight, and check that you've still got no backlash. So now we've got no backlash, we need to make sure that we've also got no binding. So to do that, we need to rotate the deck, and I like to exercise the whole of the worm gear by rotating the deck around a full 360 degrees. You see there I just changed the rate to 9 because it's a little bit like watching paint dry, this part. But rotate it, be patient, rotate it the whole way around, and what you're doing is listening for any horrid noises. It should be smooth and move freely and smoothly all the way around, no changes in sound. Any kind of binding will cause a change in the sound, so you're really listening to what's happening as it rotates. So just completing a full 360 degrees of rotation there. If there's any binding, loosen the worm carrier off again and change your adjustments again, do the process again, and then do this test again to make sure you're also not binding. You need to be backlash free as far as you can tell and not binding. So the next thing is to do the right ascension. Now I'm not going to demo the whole right ascension process, it's essentially exactly the same. The declination carrier, however, is underneath the connector box, so you have to actually undo the 2 Phillips screws that hold the connector box onto the mount. You just carefully drop the 2 screws out, and the connector box will just drop away. Be gentle and careful here because it's actually got quite a few wires on it. It will dangle on its wires. It is very light, so long as you don't put too much force on those wires, it'll be fine. But the curved side grub screw on the RA worm carrier is underneath that electronics box, so you do need to take that off in order to be able to do the backlash adjustment for the RA. So here I'm rotating it so that you can see the three largest bolts that are holding the RA carrier to the mount. So this is just showing the three bolts that you would need to loosen off in exactly the same way as we did with the deck before you start doing the tuning. And then the tuning grub screws, one is here, the flat side screw is here, and the other is on the curved side, as I said, underneath the connector box, just here. Once you've finished, you can refit the connector box, putting the two Phillips screws back in to secure it. And remember that you then need to run the RA around a full 360 degrees, listening for any binding, making sure that you've got no backlash. Rock test is the best one to do at this point. Do the rock test and run it around a full 360 and make sure there's no binding as well. And then you will be done. So I hope this video has given you some useful insight into backlash and binding, and given you the confidence to find out whether you have such problems, and if you do find you've got the problems, that you'll have the confidence also to go in and fix them. Clear skies, everyone.